This demonstration explores how system engineers, designers, and thermal experts can come together on the design and engineering of a car by combining their skills. The Experience. The high-fidelity digital replica of existing systems allows predicting usage through virtual experience in 3D, like in real life. Thermal evaluation. In order to assess driving performance, energy consumption, as well as thermal management of the car, the system engineer uses CATIA Dymola Behavior Modeling app. The vehicle behavioral model is structured with all components such as mechanical suspensions up to the very detail of the joints and 3D parts. Not only the mechanical, but the electrical, the electronic, hydraulic or thermal and control characteristics and components can be modeled with Modelica language. Let's have a look at the electrical motors on the driveline. Here in the sport car, we have developed two electrical motors, one for the front and one for the rear. Not only has the electrical been modeled, but also the thermal aspects of the vehicle. Here we can see that we can get air from the front to cool down the front motor, the battery, and then the rear motor in a single stream of liquid cooling. If we perform a sport drive cycle, we can then really assess what are the temperatures in the different components, as well as the driving performance. Here we can see at the rear of the car that the rear motor is getting too hot towards its specifications. New requirement. Brainstorming between systems engineers, designers, and mechanical engineers is managed through an innovation pipeline. To solve the heat issues in the high-speed drive cycle scenario, a solution is proposed. Fresh air will come from side inlets in order to cool down the motor with additional cooling equipment. Design changes. By using the 3DEXPERIENCE platform, the Creative Design Studio is connected with the rest of the company, and the team is using applications from the dedicated creative designer and Class A modeler roles to create the new design. By using 3D sketching on a tablet, the creative designer can quickly outline a new idea by sketching directly on the existing 3D geometry. Here, for example, he develops the needed air intake. Then, by using virtual clay modeling with subdivision surface modeling, the designer can quickly define and see the new shape of the design. The same can be done for the door cutting line and associated gaps. First, the designer sketches the design intent directly on the 3D model and then applies an automated gap feature from CATIA ISOM. By replacing the different sketch ideas that update the gap feature line, the designer can then quickly study the different design alternatives for gaps. Finally, working in a real-time, high-end visual environment with the CATIA Live Rendering app, the design manager can compare the different new design proposals for final design validation. Vehicle architecture. In parallel with styling changes, additional technical functionalities for Cooling Assistant has been added in the functional architecture to satisfy the driving performances need at high speed. This additional Cooling Assistant technical function is decomposed into allotted elementary technical functions with parameters, such as the monitoring of temperatures and switching on or off of the cooling system. These technical functions are sequenced in a scenario. A cooling system has been added in the component's architecture with allocated technical functions to provide fresh air inflow from the newly introduced side air intakes for cooling down the rear motor. Cooling system. Based on this new system architecture, the thermal models for the cooling system have been developed. Here we can see that the two side intakes directly cool down the rear motor. Let's have a look on the efficiency of our new design. Based on the speed of the car during the drive cycle, we can quickly assess on the temperature of the battery on the rear motor. First, with the previous solution, we can see that the rear motor temperature is getting up to 200 degrees. Now, with the new solution, let's have a look. As you can see, the rear motor is cooled down and 200 degrees are not reached. Play the experience. This demo has illustrated how impacts from system architects, thermal experts, and designers can be validated together, taking into account their respective requirements, while keeping the global product definition as the unique objective.